Good morning, good afternoon, or good evening, everyone. I'm Pierre-Marie Brunet from the French Space Agency, and I'm the technical manager or the product owner in Agile Scrum term of the AI4GEO project. You can see on this photo a small part of the team. The photo was taken during the kickoff seminar in March this year. So the objective of this video is to present the virtual research environment we developed in the context of AI4GEO project. So the VRE comes as a Dockerfile base image. Batteries included, I mean all important tools or library needed to interact with data, to manipulate them, to visualize them are included in this image. But it is possible to extend this image by adding some kind of overlay. So project can add their own specialized tools or specific libraries. The VRE is based on open source project. It's very close to an open source initiative named WGS. So the main two components are the Jupyter Hub and the Jupyter Lab. The Jupyter Lab is the user interface, and the Jupyter Hub can be seen as a hardware resources broker. So the first step is to sign in. And I can choose the kind of hardware, the kind of compute node I need. So in terms of context, in CNES we have an HPC cluster, a high performance computing cluster, which can be seen as a big set of compute nodes. This cluster is managed by a resource manager, PBS Pro. So when I choose a compute node for this demo, I take this one and I ask to the Jupyter Hub to start my VRE. So what is going on in the background? My request is transfer from the Jupyter Hub to PBS Pro. So a compute node is found and is reserved for me, and then the Dockerfile is launched on top of it, and I can access through the Jupyter Hub like this. And I have my Jupyter Lab that is started now. Okay, this is the usual Jupyter Lab interface that we extend by adding some tools as plugins. When the VRE started, the user arrived on this page on which he can find a lot of information, a lot of documentation on how to use the VRE. So the first tool here is EODAG. EODAG is an open source project developed by CS Group, and the key idea is EODAG is like a proxy of catalogs. So in this demonstration, we have two catalogs, PEPS and TEIA, hosted on their specific platforms, but they are registered in the EODAG plugin. So the user can see the aggregation of all the collection hosted on these two catalogs. And he can simply select one collection, start date and date, cloud cover, and perform the request. And on the fly, EODAG is transferring this request by using the targeted API of the catalog, and then expose all the results directly in the Jupyter Lab interface. So I can verify if the results suits what I need, and then apply my selection, and automatically a cell is added in my notebook. Okay. The second plugin I can present is Visual Studio Code. So I think you perhaps know this kind of tool. Basically, it comes as a client to be installed on the computer of the user. But what we done here is the integration of the Visual Studio Code directly through the Jupyter Lab plugin. So I can launch my Visual Studio Code, and for a scientific is really an advantage to have this kind of integrated development environment, and it's very complementary to the notebook. On the notebook, we can prototype some part of the codes, but when we speak of a huge code, industrial code, we need to have this kind of tools to develop more easily and more efficiently. So this is the standard interface of Visual Studio Code. You can have your code, you can browse your files on the left, you can edit your code on the right, and it's exactly what you can have with a client directly installed on your computer. But the objective, very important for us on this VRE, is to be non-intrusive on the client side. So the end user just need to have a browser, and then it can access to all of the tools we provide. The third plugin I want to present is the desktop. Because some of very interesting tools such as Visual Studio Code doesn't have an HTML rendering, an HTML API directly available. That's the case, for instance, of QGIS or Monteverdi. Um, so we integrate directly, so because QGIS needs to have a X server. So we directly integrate an X server and a desktop complete environment as a plugin. So this is based on the VNC protocol, which is rendered directly through the browser. And it's available as a plugin, as a starter of the Jupyter Lab. And through this, I can have all the tools and launch all the tools I want. I just need to have them installed on the VRE, inside of the VRE. So it's very powerful because by doing this, you can use a very different set of useful tools specific to your business, specific to your enterprise, or and so on. And also, one thing very, very interesting with this is that when I launch my QGIS directly on my computer, I have some hardware limits, such as memory, but here I'm directly on the compute node with more than 100 gigabytes of memory, so I can manipulate very easily huge kind of data that are not feasible directly on my computer, on my laptop. And that's all I can tell for the first part. So the objective of AI4GEO is to release all the developments in open source. So we are totally open for collaboration with other agencies or laboratories. So if you are interested by this kind of approach, please come to see us, and we can keep in touch and perhaps work together in the future. Thank you very much for your attention, and I'll try to be present during the live session to answer to the question you might have. Bye bye.